I'd like to welcome you to another video on Microsoft Access today. Today I'm going to do it in front of one of my favorite cars in the whole world. I love this coupe. I wish I had one. There's no way I could ever afford one, but I can always just look at pretty pictures and along with a lot of other people, I'm sure, just enjoy the fact that other people have them on the road that you can watch and look at once in a while. But what I'd like to talk about today is calculations and dates that you can put into your database to analyze the data. Okay, so in databases, the formulas that you use for analysis are separate from the actual data. In a spreadsheet, for example, you have them embedded in the data. In other words, you have it in the cell that creates the actual calculation. So in that respect, an access or a database is very different because the calculations are always embedded in queries or in other places in the database instead of with the data. The data tables, in fact, in order to be third normal form, don't have calculated values in them. E.F. Codd ruled that out in his rules for the first three normal forms. So what we want to do then is to show you how to build those queries. So I'm going to pull up a database and show you a few examples of the ways that we build formulas and make sure that they are in the database. So I'm going to go ahead and pull open this one to begin with. And what you'll see here is a query, and what this query has done is it has grouped the data by market. It has counted the number of orders in each market. It has added up the revenue in each of the markets and then has averaged the dollar value per order. Pretty cool. This query is doing a lot of work for us. So let's look under the hood and see how it was done. One of the first things that you notice, and let me pull this down a little bit. First thing you notice is that it is a totals query. Okay. So it is an aggregate query that is doing the count for us, and then it is going ahead and summing the revenue. And all this is old news. We've already talked about that in previous videos. The next thing, though, is we throw in a calculation here. And now notice that in throwing out the calculation, throwing in this calculation here, we've referred to our EV, which is revenue here. That's the tagline. It could have been line total. We could have put line total here, or revenue. If we had built it as, if we decided to leave this label off, it would have been line total. Order count over here. Here we have order count, the alias that we put on this field for PO number. So PO number, we just totaled the number of PO numbers in that particular market here. So here we've done and taken the revenue divided by order count to come up with an average. And notice in our list of items that we have available for our totals query, expression is one of those, as well as group by, average, and so forth. Okay, so expression. Now, we would not want to use average in this case because the average it would come up with there would not be the average per market. It would be the average of all of the POs. If there were POs in other markets that we excluded, it would still put those in the average. So that would not be accurate. So doing the math here is actually a more accurate representation of the item. Okay, so when we run this, we of course see then that we get an average dollar order. Okay. Oh, I want to do one more thing to pretty this up. This average dollar order, it's not in dollars. It's got this gross number of digits here. It's not readable. If I was to pass this off to a user, for example, what could I do to pretty this up, okay? So let's go back to the design view here, and let's go over here to my property sheet. My property sheet has a line called format here. Well, by default, it's going to give you, I believe it's 17 total digits in back of the decimal point, and it's going to give you the major digits to the left of the dollar, the left of the decimal point, Yeah, that's kind of a given. But if I want to put it in a format that is currency, so that it looks like my revenue line here, I could do that. Also, I could tell it specifically the number of decimal places. And let's make sure that that goes out 2 decimal places so it looks like a normal currency, okay? And then if we view that one, we've now prettied it up. We now know that the average dollars per order is the way we want it to look, okay? So let's go ahead and close this one. Let's move on to the next one, okay? So let's go ahead. Yeah, we can save this. Let's go ahead and look at this query here. Now, this query, of course, has been prettied up. We have in this query a value here, and of course, we have the markets here, so you're familiar with that. We have the adjusted forecast, which is I'll show you the calculation that they put in here for adjusted forecast, and then we have the new variance, which is going to be actuals minus this adjusted forecast. And that's a typical finance type calculation that you'd do if you were a finance person working at a company. So what they want to do is they want to adjust the forecast downward 10%. So they multiplied forecast times 0.9% to adjust it downward by 10%. And then that became the adjusted forecast. And then they went ahead and took the field actual, which comes from the table forecast summary here, the actual minus the adjusted forecast. So they're moving the adjusted forecast downward, possibly believing that maybe they're not going to hit their totals or something. And at that point, then we could pretty this up by making sure that this is a currency, and that this is also, I believe it's also already a currency, but we'll just make sure that that's fixed like that. And now we have the new variance being 156,000 here versus the 1.9 million there, okay? What you'll notice is that all formulas, if they have a null value in either one of the fields, like there's no actuals or there's no adjusted forecast in there, you'll just get a blank value. It'll remain null if any one of the values in the fields that you're using are null. So thus we have up here in Baltimore, and I'll tell you how to deal with that a little bit later, okay? So let's look at another way to use a formula. So I'm going to go ahead and save that change. And in this one here, we're going to look at an average over here, an average per period in this case. So let's go ahead and look at the way that they constructed this average per period. Okay, and notice I didn't have to have the period in the actual query. All I have to do is have it in the underlying data used by the query. So I don't have to show period. I don't have to show the total of number of periods and so forth and so on. So let's, in this case, what they're doing is they're looking at period as a quarter. And a typical quarter has 13 weeks in it. 13 weeks times 4, you'll notice, is 52. 52 weeks in a year. So we use 13. 3 months you'd think was 4 weeks each. 12, but not actually. Just like a year isn't actually 365 days. It's 365.25 days. So you have to kind of understand how the data and calendars lay out in order to get the accurate numbers here. But so average per period, we're going to sum here the total divided by 13, and the markets are going to be grouped. And that's all that took place here. A very, very simple expression there. And notice we're letting the totals query do some of the work for us by grouping the data in markets, allowing us then to sum the number of records per market over here. Okay, so that one's pretty cool. Okay, now when I run this one though, one thing that I want to address here is that what happens here, average revenue per period has got this huge number of gross, decimal places here. That's not what we want. And in the other things, I've concatenated them by simply using a currency and telling it to go only to 2. I've shortened them only to 2 decimal places. Let's show you a different method to do that. Let's say I don't care about decimal places. In fact, a lot of times when you're dealing with a large company like I work at Boeing, when I'm putting out financials, they don't want to see anything less than 1,000. Sometimes the reports roll up and they don't want to see anything less than 1 million. So they'll see 10.4 million, and that's the farthest precision that they want. Well, in this case, if you want to see just the amount of decimal precision that is, let's say, just down to the dollar, we can easily just go and put another calculation in here. So within the parentheses, the sum parentheses, I'm going to go ahead and use another formula called int, which stands for integer. And I'm going to close paren there, okay? So I'm going to sum the integer values of the line total divided by 13. And when I run that, then I get just the significant digits to the left of the decimal place. So integer is one way to use. Now, a little bit of caution with integer. All integer does is just lop off. It just lops off everything back after the decimal place. But what happens if you want to round them? What happens if you want to deal with only the values rounded to the next decimal place instead? So let's go ahead and go back here. And I want to introduce you then to another way to build a query, and this is the builder up here. So now we can see the formula here, and this whole dialog box is meant simply to help you to build formulas. And the formulas you find under here in the built-in functions here. Now, this box also expands to where you can make it big enough to see everything that's going on. And so I want a math formula here, okay? And what I want to do is I want to round something. And to round something down here, it gives you the instructions how to deal with this. In fact, if you click on this, it opens up into a web page and it says it's unable to respond to the service. Well, that's wonderful. Sometimes Microsoft Help is so helpful. So because we're not going to get help here, this is about all the help we need. So when we round something, we want the number here, and that number can be the value coming from the database, okay? So with the value coming from the database, the next thing is how much precision do you want? Do you want 2 decimal places, 4 decimal places, 5 decimal places, that type of thing? So we just put a number here. So what I want to do then is I want to get rid of int here. So I'm just going to remove the open and close parentheses for int there. And I want to round the sum of that. So that's my number. And I want to go to 2 decimal precision and close it. So that's as simple as that formula is. What I have done is I've followed this thing here. The number was my old formula, and the precision is going to be 2. And when I click OK on that and I run that, you'll see that I have now put the precision out to 2. Now with the rounding function, of course, different from the integer function, where the integer function simply lops it off, now you have a much more accurate portrayal of the data. So this could be 312 over here, but if it were 316, for example, you would then see it be 32 if I put it back to 2 decimals. So it rounds in the way that you would expect it to round, okay? Now, how do I deal with null values? If there's a null in your formula, a lot of times there's fancy ways to look at null values. You can use an if-then statement. You can do all kinds of different ways of dealing with null values, but here we have a null value up here in forecast. I want to fix that, okay? So I'm going to go ahead and put this in design view. I got a forecast summary up here. I'm going to leave forecast there. That's fine. But you'll notice that over here, that I use the formula, the function called NZ, okay? Non-zero. So in the forecast, if forecast is null, I'm going to fill it with a 0, okay? In fact, I could go over here and I could put this piece of the formula here, right there, and FCST colon and go that way. And now let's look at this. Okay, now I have in my forecast, okay, I have a 0 here, and the variance now is all filled in, because now I can see that this minus this now equals that. That NZ function allows you to fill in those values with a value that you determine, by the way. Notice I told it to put a 0 in there. I could also tell it to put 1,000 in there, 100 in there, whatever value I wanted to. That value simply is chosen by me based on whatever I need to put in there. Okay? So formulas are fun things to work with. So let's work with a little bit on dates. Okay? Let's see what a little bit we can do with dates. So I'll save those changes. And I'm going to open this, okay? And here we've got kind of a weird bunch of information. We've got the year, the month, the day, all in separate lines, okay? So let's go ahead then and look at what they've done here, okay? What they did is they went to the transaction table here, and they just took they literally just took this order date here. In other words, you notice over here that it's all separated into the various fields. Well, it wasn't that way in the original data. What this is here for is just to illustrate that you can manipulate any date field. Now, it has to be a date field, okay? And there are several different types of functions that allow you to tweeze out just the year or just the day or the day of the week or the month, whatever. So what you've got here is the year, and the year open parens order date, okay? And then month, here you've got a month function, you've got a day function, and you've got a weekday function, okay? Now, one thing that I like to do is I like to do a switch statement, which is coming up in an upcoming video. A switch statement that would allow me to take this weekday here. Notice when I do this weekday, it just returns a number, okay? The number is the weekday. Well, that weekday represents Friday, all right? 1 is Sunday, 2 is Monday, 3 is Tuesday, so forth until you get to Friday is 6, and Saturday is 7, okay? Last day of the week. So those weekdays being a numeric value, I can take a simple switch statement or an embedded if-then statement and take that number and turn it into Monday, Tuesday, Wednesday, Thursday, and play with it like that. So in separating it out like this, I can be able to tell what day of the week the order was done in this case. So there's a lot of things you can do with that. Now, one thing that's also nice is you can take this order date, and let's say that there is a delivery date in this data someplace, or there's the ship date. You can take the order date and minus the ship date. So it took them 10 days from order to shipping to get the shipment out the door. So you can do math on a regular date function. As I did there, you can figure out what day of the week, what year, what month, and so forth. And then once you know what year or month it is, you can always, do other math on just the day of the week or just the how many years an employee's been with the company, so forth and so on. You can deal with that. So that's it for this video. Hope you've enjoyed it, and be sure to come again later. Talk to you later. Bye. I want to thank you so much for coming and watching this video today. There's a lot of other great content that you can explore on this channel. In fact, a link to one of them is on the other side of the screen here. Also, please take a few moments to subscribe to the channel. It'll keep you informed of new videos as they're posted, and you can keep up with all the great content that's being put out here for everyone to enjoy. We'll hope to see you again later.